Today we are going to discuss the last application of Gauss law. Earlier we have discussed application of Gauss law for line charge, another one for plane sheet. Now today we will discuss the application of Gauss law to find electric field due to charged thin spherical cell. So let us now discuss this case of the Gauss law. As the spherical cell is hollow, we are considering, so there are three possibilities. First, electric field outside the cell, on the surface, and inside the cell. We will take up each cases one by one. First, outside the cell. Let us here a hollow cell having the charge Q. Its radius is R, and at point P we want the electric field. Through P we have to draw first the Gaussian surface. The radius of this Gaussian surface we are taking a small r, and let us say small area ds on that Gaussian surface, whose area vector is radially outward. So the electric field vector and area vector is along the same direction. Now if we use the Gauss law, we can write flux, electric flux is equal to surface integral E dot ds q by epsilon naught. So here electric field throughout here is the uniform. So summation of this element area will be 4 pi r square small r, that is equal to q by epsilon naught. So we can write E into surface integral ds equal to q by epsilon naught, or E into 4 pi r square equal to q by epsilon naught. So here see E equal to q by 4 pi epsilon naught. It is as similar as the electric field due to a point charge. Since q equal to sigma into 4 pi r square, where sigma is the surface charge density of the hollow spherical cell, so therefore E equal to sigma r square by epsilon naught r square. Next we will take up the point on the surface of the cell. Let it here a hollow sphere of radius r, same we are taking, same spherical cell, and we want at this point electric field. So the Gaussian surface will be same as the surface of the sphere. Again we will take a small element area at point A, whose area vector will be this, and electric field is also along the same direction. So now if we use the Gauss law, we can say electric flux equal to surface integral E dot ds is equal to q by epsilon naught. So as we have solved in case 1, here only one thing, that the summation of this area ds will be 4 pi r square. E into 4 pi r square equal to q by epsilon naught, and if we substitute the value of this q, that is sigma into 4 pi r square, we will find the electric field on the surface of spherical cell is sigma by epsilon naught, which is its maximum value. Next we will take the point P inside the cell. Cell is of radius r. Now here we are taking point B, which is inside the cell. So first we have to draw a symmetrical Gaussian surface through B. Obviously that will be a spherical. Here we are taking the radius of this Gaussian surface is r dash. So if we use the Gauss law to find electric field at point B, we have to use once again surface integral E dot ds equal to q by epsilon naught. Here area vector and electric field vector are in same direction. So we can say E into 4 pi small r dash square equal to q by epsilon naught. But what will be the value of this q? Inside, if we see this Gaussian surface, there's no charge. All the charges are on the surface of hollow spherical cell. So the value of q is here 0. So ultimately we can say electric field inside the hollow spherical cell is 0. This property of cell is used for electrostatic shielding. Here we have dealt with the three cases: electric field outside, electric field on the surface, and electric field inside. So now if we see the graphical view E versus R, we will find the graph is as drawn here. Electric field on the surface will be this one, and its value will be sigma by epsilon naught, which is maximum. If all three cases be summarized, that then we can say E outside means small r is greater than capital R is equal to sigma r square by epsilon naught r square, and it is q by 4 pi epsilon naught r square as the electric field for point charge. Again on the surface if we see this small r here is replaced by capital R, so its value is sigma by epsilon naught. If you remember the plane sheet, it resembles with someone, so try to find out which case. An electric field inside is 0 because inside charge is 0, and it is the graph. In the next class, we will start the second chapter of electrostatic, that is mainly deal with the electrostatic potential and the capacitor. Thank you.